Saxon Algebra 1, Lesson 25. Hey, you guys, we're going to get into actually solving equations today. And before we begin, we want to remind ourselves of the first and second rules of algebra that we use when we're solving equations. Now, if you want to see them written in precise mathematical academic language, here they are right here in lesson 25 on page 106. I'm not even going to read them to you because they make my head spin, but that is the way they're stated most precisely and most accurately. What I'm going to do is restate them for you in simpler language that will get across the main points. When we're solving equations, we can add or subtract any number to the equation as long as we do it to both sides. That's the first rule. The second rule is that we can multiply or divide any non-zero number as long as we do it to both sides. When we're on the multiplying and division side, we have to say non-zero because we can't divide by zero. That would make the kingdom implode, and we can't have that. All right, so these are considered the first and second rules of algebra, and they relate to solving equations. The third rule we use all the time, but I don't want to talk about it today, but it relates to expressions rather than equations. All right, let's see these rules in action. You already know how to do this. I know you do. Solve. Solve, when we see that word, that is a heads up that we have an equation. We can't solve an expression. We can only simplify it. Simplify means it's an expression. Solve means it's an equation, and that is a great hint for us. 4x plus 5 equals 17. Okay, we see our equation. We know that we're solving. The next thing we do is we look for our variable, x a lot of times. It can be anything though, it doesn't have to be x. And we look to see what's happening to it. Well, it's being multiplied by 4, and it's also being added to 5. So we have to undo two things, don't we? So how do you remember which one to do first? Well, here's my story. Have you ever been part of one of those trio of friends where there's three guys, well, you're guys, so I'm saying guys, but it could be girls too. Three people who are great friends, but there's always two who are a little bit closer than the third. And it hurts to be that third person. Man, I've been that person. It's way more fun to be one of the besties. So we're gonna imagine these three symbols as being the three trio of friends, 4, X, and 5. 4 and X are the besties, and 5 is kind of chilling over here. You know, he's kind of the third guy. It's sad. So when we go to solve these, we go, well, he's gonna go home first. You know, they're all hanging out over at X's house, but this guy's the one who's gonna go home before dinner, and 4 is gonna get a secret invitation to stay. Oof, it hurts. But that's how we think of this is, okay, he's clearly not, this is the BFF. So he's gonna go home first. And we do that by taking the opposite operation. He's being added, so we're gonna subtract him. We have to do it to both sides because our rules say so. So now 4 and X are still hanging out, but this is gone. And 17 minus 5 is 12, right? Oh, Grace is upset. Someone's in my kitchen making noise, and it is just harshing her above. Grace, it's okay. Do you want to go in and see? Hang on. Dogs come before algebra. Sorry. Grace is freaking out. Good girl. One of my daughters is in the kitchen. She's been working on a project to clean her Legos. She's 26 years old and she's cleaning her Legos, you guys. She has priorities. And she was clicking them, but she was listening to something on her headphones, so she couldn't hear the dog was barking. That's what happened. All right, so 4 stays for dinner over at X's house. 5's long gone. He got sent home. And X says, hey, Mom, can 4 spend the night? And she says, no, I'm sorry. It's a school night. 4 needs to go. So it's time to send 4 home. And the way we do that, these two are being multiplied, which isn't always crystal clear. But when they're next to each other like that, that means multiplication. So we're gonna have to divide. That cancels because 4 over 4 is equal to 1. So 1 times x, we don't need the 1, so we can just cancel that. And we get, I'm going to write it over here, x equals 3. All right? Hopefully this all sounds really familiar. Maybe not the part about the BFFs. Jackson, you weren't entertained by me last year, but Caleb was. So that's just the way, that helps me remember which to deal with first. Which is weird too. Well, never mind. I'm not going to say that. This formatting is a big deal. Make sure you follow it exactly the way I lay it out. Let's do another one. 25.2. Solve minus 5m plus 6 equals 8. Okay, same scenario. We have an equation. There's our variable. Oh, it's the old trio, the Three Musketeers situation, right? Minus 5 and m are the besties. Positive 6 is the third wheel. Dang it, it's so hard. So it's time to send him home first, and we're gonna subtract 6, right? We do the opposite of whatever's happening there because plus 6 and minus 6 goes to 0. The minus 5m stays the same. 8 minus 6 is 2. Okay? Now, this time, it's the very same thing where, you know, he stays for dinner and M says please and Mom says no. So we do the opposite. These are being multiplied, so we divide. And dividing by a negative number, it's no different. We just have to remember to make sure that minus sign is clear over there. Minus 5 over minus 5 is 1. We don't need it. And we get m equals, now look at how I'm going to write this. I'm going to bring the minus sign out and write the numbers in the fractions as positive. As much as I hate floaty numbers, I'm cool with floaty signs. So that is that's our answer for this one. Oh, and I didn't smiley face this one. X equals 3? Yes. Okay. Next one. Ready? Solve. Minus 7k. Does it make a difference if it's a different letter? No, it's exactly the same. Minus 4 equals minus 21. Ooh, we're getting a run on negatives. All right, but the process is exactly the same. We're over here. There's our k. We see the equal sign. Cool. You're the one that's going home first. Both sides. This one cancels. Minus 7k equals, now, minus 21 plus 4. The difference is 17. The bigger number is the minus, so that tells me minus 17. And now we divide by minus 7. That cancels. K equals, oh, and look, 2 minuses make it all go positive. So k equals positive 17 over 7. All right. 2 more, 3 more. Example 25.4. Solve minus 11p plus 5 equals 17. One thing I will say about these random letters John's throwing at us, it doesn't matter, but sometimes there are some letters I don't like to use. For example, I don't like to use S's because they look too much like my 5s. And I can get confused. So if I see a problem with S in it, I can change it to an X or whatever I want. And then at the end, I'll just write, like if I get that the answer is 32, I'll have worked the problem with X's. And then at the end, I just write S equals 32. So it's fair to do that. That's fine. All right, same process. Here they are, the Three Musketeers. You guys, have you ever been in the situation where you used to be one of the BFFs and then something changes in the dynamic and suddenly you realize, I'm the friend who's going home before dinner? That's rough, isn't it? That happened to me when I was in, I think 9th grade maybe, where I was one of here and the third girl, her name was Kathy, was over here. And then there was one terrible spring break when the third girl invited the one who was usually over here. She invited her to go to Disney World with her family. And I became that one. Oof, not fun. Okay, there's our P. We subtract the 5. That goes away. Minus 11P equals 12. Divide by minus 11. P equals minus 12 over 11. Improper fraction, that's the way we want it. No mixed numbers. This one looks like it's up high. It shouldn't be. It's floaty. It's a floaty in the middle guy. All right. And example 25 over 5. Finally, something that's a little different. The purpose of all those examples so far were just to show us that pluses and minuses, it doesn't matter. We can handle any combination. This one's a little bit different. We have an equation with fractions. The good news is when we have an equation with fractions, we can blow up the denominators. And we do that by first finding the least common multiple. What is the least common multiple of these numbers? Well, 2 goes into 4. So if I can make 4 and 5 fit, I know 2 will be fine. 4 and 5, that's going to be 20, isn't it? Now, watch what I'm going to do. Now, by the way, John doesn't teach you this yet. I'm not going to waste your time with a bunch of dumb fraction work. We're going to blow up the denominators right from the beginning. So what we do is we multiply every part of the equation, every term, by the least common multiple. And I like to write it up and kind of at an angle like that, because I don't write anything else like that and it reminds me. Now, look what happens. These two cancel. 5 goes into 24 times. So I'm going to cancel that and write 4 times whatever was there to begin with. 2 and 20 cancel and make 10 times. 20 and 4 cancel and make 5 times. So I can write my new number in front of the existing numerator or after. Order doesn't matter, just wherever I have more space. Now I've got 4m minus 10 equals 15. What do you think about that? That is advanced, you guys. John doesn't show you that in the book, but I think you're ready for it. And here's the thing. As soon as I see those fractions, I want to get rid of them. I do not want to deal with them. So we blow them up by multiplying by the least common multiple. All right, now we just finish our usual procedures here. 4m equals 25. Notice every single time I do that. Divide by 4. That cancels. M equals 25. Happiness. And one more that has another little drama situation that we're going to learn how to fix. We learned how to fix fractions, right? Now we're going to learn how to fix decimals. 0.4x minus 0.2 equals minus 0.16. Okay, so we also can blow up our decimals. Sorry if this is a little violent. I don't think you guys would mind a little bit of explosions in our math work, right? Okay, we know that we can multiply numbers by powers of 10 really easily, right? If we want to multiply everything by 10, we just bump the decimal once. If we want to multiply by 100, we bump the decimal twice. So multiplying by powers of 10 is super easy and it gets rid of decimals. So we look at our 3 terms here and say which one of these decimals is giving us the biggest problem and what would it take to make the problem go away? Well, that's 1 decimal place, that's 1 decimal place. This dude has 2. He's the troublemaker, right? But we see if we multiplied by 100, that would go away because look, it would go 1, 2, and our decimal would be there. So we can do that. We can multiply every term here by 100. Just like here we multiplied every term by 20. This one we're going to multiply every term by 100. But instead of writing it up above, we're just going to bump the decimal over. That becomes 40. 1, 2. That becomes 20. And this one we fix to be 16. So we look for the decimal with the most places and multiply by the power of 10 needed to make that one, the decimal, go away. So now we have 40x, minus 20 equals 16. Do you like it? And then we add 20. And we get 40x equals 36. And then we divide both sides by 40. I'm slightly perplexed. $20. Oh, that's a negative, sorry. Negative 16 plus 20 is positive 4. There was my mistake. I lost track of my minus sign. You guys were probably watching and being like, the minus sign, you forgot it. But I finally figured it out. Okay, so now I have 4 over 40. That cancels, and this reduces to x equals 1 over 10. And I look at the answer and I see John has written x equals 0.1, or he actually wrote 0.1, and that's the very same thing, isn't it? So I am fine with an answer in fraction format. You know how I feel. I prefer fractions to decimals. Like most mathematicians, I have a preference. And most mathematicians prefer fractions. Most scientists lean in on decimals. So either of those would be the right answer, and I would accept them gladly. That is lesson 25, my lovely students, and I will join you back for lesson 26 shortly, in which we're going to do slightly more complicated equations. Thank you. Goodbye.